All right. And we're live. Testing. Let's see, we got audio. Testing. Let's see, we got audio. Testing. We got audio. Testing. Where's my audio? Testing. Where's my audio? All right, sounds good enough for me. Ooh. I am ready to start the video, I think. I think we're live. I think we're good. Let's see. All right, welcome to Redneck Robotics. This is a robot. It's an old Flsun Delta printer. This is a box of upgrades. We're going to upgrade it. So, first off, let's talk about what we're going to do to it first. So we've got the Big Tree Tech Pi, version 1.2. We've got another Big Tree Tech, TFT35 for the screen. And then we have an SKR3 for the 32-bit mainboard. It's the regular SKR3. It's not the easy. It's not the ones for other printers. Just a standard SKR3. And then we got some aluminum milled corners, because these plastic ones, I noticed they started to get a little warped and they're not quite lined up right. They're not quite straight. So we're going to fix that issue. And then we've got some Capricorn Bowden tubing right here. Highly suggest the Capricorn tubing. It's a lot better of a tolerance. We've got some rubber GT2 belt, pure rubber. I'm going to be tensioning these with springs, so that's why I'm using rubber. If you're not tensioning with springs, if you're tensioning with just a screw, I suggest using, what do you use, fiberglass. Doesn't stretch quite as much. We got some really, really small cable management, whatever this is. Let's see, what do they actually call this? Spiral cable. So the small stuff is for putting the cables around the board, tying them down. Have some cable management in there, because as you'll see when I take it apart, it's really hard to do that without some form of proper cable management. This is another cable shield. I'll be using it in place of this to go to the effector and the hot end. We've got some JB Weld quick weld, using that to make the rods. The rods will be another video, because I'm still waiting on the carbon fiber and the rod ends and all that. There's a sensor thermal probe right here. It's the, I believe it's the PT1000 or PD1000. And then we got a dual gear extruder. I haven't tried these out yet, so this will be my first dual gear. See how well it works, how much torque it can provide, see if it skips. Got a bunch of fans, 40 mil, 4010 fans. We've got, or JB Weld. These are the springs that I'm using. I'll show you how they work later on a little closer, but see if I can get one out here. These will hook on to the GT2 belts and hopefully give equal tension across all of them. The idea behind them is if one belt's looser than all the others, then it'll tension the spring less. And if one belt's tighter than all the others, it'll tension the spring, other way around. It'll tension the spring more, kind of equalizing all of them. And with Delta printers or any printer in general, if your belt or your belts aren't all exactly the same tension, it can actually change how much they move because of stretching and displacement. So if this tower has a belt that is tensioned a little more than this one, then I forget which way it goes, but one of the two, when you send, say, a move 100 millimeters command, it'll only move, say, 94 compared to the other one moving 100. And everything could be set up perfectly, exactly the same, except for the belt tension, and it will actually change the distance that it moves. So getting the same tension is always a good idea. We have some 20-toothed idlers. I have smooth ones on here right now that it came with, and they're not the best. I wouldn't suggest smooth ones. They'll kind of eat up the teeth, first of all, on the belt, but second of all, a lot of the smooth ones, since they don't grab the belt, they won't guide the belt properly, and the belt ends up going up on the ridge on the side of the idler. So we're going to fix that issue. Got I forget what they call this one, but an upgraded heater probe. For the hot end, I'm going to say that one's 60 watt. I'm running all on 12 volt right now. And then we have some pulleys for the motors themselves. Some JST XH connectors. I know Big Tree Tech gives you some, but I just wanted a little more, just in case. And then, over here, got some linear rails. And I upgraded 2 of the 3, and then I'm saving the upgrade for this one for the video to show you how to make these not awful. Because when they arrive, they bind the little balls, they're coated instead of solid, or they're plated with something, usually chromium. And any pressure on those bearing balls will crack the chromium, and you'll have little flakes of metal inside your bearing. That's not a great thing, obviously. So we'll do that upgrade when the time comes. And then here, I have some silicon nitride bearing balls for it. It's essentially a type of ceramic. And with that, first of all, you won't get that cracking issue because they're solid, not plated with anything. And second of all, ceramic bearing balls tend to polish the surface of the bearing that they're on. So if your linear rails arrive kind of messed up, scuffed, or unpolished, then that type of bearing ball will eventually polish it down smooth. And then the grease that I'm going to be using is, you can get this at your local auto parts store or whatever. But white lithium grease is what I recommend for linear rails, for the reason that there's no solids in it. They use a lithium soap, is what it's called. So that lithium soap dissolves into the grease that they use, or the binding agent that they use, and you have no solids in there. Unlike the PTFE-based grease, that has little tiny nanoparticles of PTFE in it, Teflon, and what that can do is get caught underneath one of the balls and end up letting it slide instead of roll. And you don't want that, because you'll get flat spots in your bearing balls, and eventually it won't work anymore. And we don't need you up here. Come on. So, gonna pack all this up, start tearing her down. So a little bit of background on why I'm doing what I'm doing, how I know what I'm doing, all that. I have been building Delta printers for, I'd say, a good 5-ish years now or so. Done a lot of research into Delta kinematics and raw stock printers and Kossel robots and all that. And because of that, I feel that I can make them better. Because Deltas seem to have kind of fallen off the face of the earth in the last couple of years, because originally they were meant for speed, and the Core XY printers kind of have the market in that now. So, my goal here is to get Deltas back on top, get some good speed with good accuracy as well, because the accuracy is important. You want your part to work as intended, or whatever you're printing to look as intended. So right now I'm just taking the extruder apart, pulling the motor off. I'm going to pull the bracket off here. And most everything that I'm using is either M3, M4, or sometimes M2 when you get into the small stuff. So there's our extruder assembly right here. Go ahead and unscrew all of this. Keep these all together. All right. And next, I think I'm going to tackle these carriages. I'm going to take the rods off. And a little tip about the rods, which if you've been watching Delta printer videos in any way, I'm sure you know, but these all have to be exactly the same length. If they are not exactly the same length, then you'll start to have issues that the software has a really, really hard time accounting for. We got that out. Take this one out. And the second I take this screw out on the second carriage, everything's going to fall. So be mindful of that when you're taking these apart. You don't want anything to bend or break, smack into stuff. So, like that. So be careful. And like I said, I am going to be putting these arms back on, these rods, because I'm waiting on shipping from China. I'm sure we all know how that is. It's actually not quite as bad as it used to be. It used to take months. Now it usually only takes a month, but still gotta wait for it. Pull this bone tube out, and here we have, I don't know if y'all can see that. Here we have our effector with the rods on it, hot end and all that. So I'm going to start disconnecting all those. And let's see if I can get you guys set up a little closer. So you might have a chance at seeing what I'm doing. I have everything set up over here to show you the linear rail upgrades. Move that out of the way. Let's see just how close we can get. Right about there. Let me go ahead and check. Yeah. I'd say that looks all right for the fine details. All right. So, let me get this wire unwound. I essentially twist tied the silicone sock over the key block because it was falling off. So we're going to fix that. Some redneck ingenuity right there. Let me get that off so I can show you what I'm doing. All right. So this is our effector. This is how it sits. There's the hot end. I'm going to pop this off. You can see what we're doing. And then we've got, should be an M2, nope. That is 1.5. Let me grab an M2. This one, yep. All right. So right here, unscrewing that a little bit, and then you may need to grab a flathead, put that into the heating block like so, and just ever so slightly lift it up a little, and you can pull your heater cartridge out like so. And then you're gonna grab, this is probably we'll grab an M1.5 and unscrew that area. And that's what holds in your thermistor. So we've got that undone. And then I'll take my part cooling fan out. And then this is a trick that I kind of thought of, I guess. I'm sure I'm not the first one to do it, but on these, this is a dragon hot end. You've got that tube right there in the middle. It's metal, it goes straight to the tip, to the nozzle. So in that tube, I just connected a switch wire for the end stop. And then I connected the other end stop wire to my metal build plate right here. And as long as you have the metal side facing up, you can use the nozzle itself as a probe. And it's a lot more accurate. Most accurate way I've found to do it, and it's just 2 wires. I've tried the piezoelectric probes and BL touch and all that, and they don't get anywhere near just using the nozzle itself. Definitely have to make sure the nozzle is clean, very clean, because if it's not, you'll crash into your bed. If there's that little extra film on the bottom of the nozzle from printing, a little extra plastic, then it'll insulate from the bed, and you'll end up just jamming it straight down into it. But there's all our stuff from the hot end. This is just a LED that I made. And then we'll pop the bed off. Let's take this wire out because we're upgrading pretty much everything. That'll connect differently, reroute the wires and all that. So there's that wire, I just stripped it. And here's our spring steel, the PEI on the top. There's the magnet that holds it. It is dirty because I haven't used this printer in a good long time. So, I'll go ahead and pop the bed off and definitely clean it off. And I've got a new pack of M3 screws that are all black, so I'm going to use those when I reinstall everything. But got to make sure if there's any spring washers or anything like that, you reuse them where they were. For instance, at the rods, they have spring washers on them. Alright, so we'll lift up our bed, pull that off, and now we're at the brains. And like I said, it is not easy to cable manage in here. You can tell I kind of gave it a shot, but it's still a rat's nest no matter what I did. So, get all that dust off. Oh yeah. Anyway, so what we'll do here is start unplugging everything. Here's my USB connection that I connected to my printer, or to my computer. I was running Marlin on this, so just a straight connection, no Wi-Fi or anything. And then I'll show you what this is in a minute once I start disconnecting everything. But it'll save you a lot of headache and damage later on. I'm going to take off my screen plugs right here. Take off all my end stop plugs. These 3 are the switches 4 up there. And then this one should be my probe. Yep. That's my using a nozzle as a probe plug. And then we'll take the bed thermistor and hot end thermistor out. Not a good idea to pull them by the cables like I was, but if you do, be very gentle. And then all of my fans right here. And as you can see, I didn't have enough fan plugs on this board. This is an SKR2, so I spliced these two together. Worked just fine. Then we'll unplug all of our stepper motors, XYZ, and here's the extruder. Now all we got is power. We can actually just unplug this one, set it aside for a minute. And then these two, these flatheads. I'm sure this one will fit. There we go. And then this one is for the bed. So unscrew those. There's my bed. Oops, sorry, that was. Oh, yep, that was the bed. And this is power in. Take that. And there's our SKR2 control board. We'll get this out just to keep everything together. And I'm walking you through every process here because people seem to get a little scared when they're looking to put together a Delta printer because they're funky looking. Everything has to be very precise. But if you get it right, they are fast and very accurate, which is what I like. All right, so this is essentially a giant MOSFET. And what that's for is I put regular power supply power straight to it, and it takes that in here, and then I just spliced out from right here to the board. So I got one line going into here to the board. That's all on 12 volt. And then this little plug is the PWM control for the heated bed. And that just plugs in straight where you had your heated bed plugged in. And what this does is it obfuscates from the board power. It's essentially sort of like how you'd use a solenoid. So the bed is only powered straight from the power supply. It's not powered through your board then to the bed. And the reason I did that is I upgraded my bed to a 200 watt, and these little surface mount fuses were popping because of that. Because there was too much current going through the board. So I popped that off and just attached it into here, and this gets its own separate power. Doesn't go through the board. The board has some freed up current. So we're going to take this apart. Set it aside for later. Wires. And there's my power in. And here's my power out to my bed. Alright, so there's that. Set that aside. second here. All right. So next step, split everything up to reorganize everything. So there's my fans. Here is everything that goes to the hot end in the bed. All right. There's all that. And then this, I use standard Ethernet cable to get the wire and put a 5-volt lighting system in. There's 3 LEDs on each tower. That's what this is. So I'll unravel all this, take those out. And this might take a minute. By the way, I really like these spiraled up cable management sleeves. Really handy. Mainly because you can poke wires out the side all the way down the sleeve and not have any funny spots. But I'm going to be using an actual pull-through sleeve from now on because I'm upgrading all the way. I'm not planning on doing anything else to the hot end, so if I need to fix something or something, then I can pull everything out if I need to. But otherwise, I'll just leave it how it is once I'm done building it. So just me unraveling everything. Just super fun. Now I could just yank on it probably, but I don't want to mess it up because I'd like to reuse this. Pretty far down, so I'll start the other end now. Start unraveling there. All right. There's that. Set that aside. And here's all our wires. Here's the lighting. Here, let me go ahead and zoom out again so y'all can see everything. Oh shit, camera went out. Let's see what's going on here. There we go. All right, we're back up. Cool. Got some zoom out while I'm looking at the bottom. All right. Next, I think we should unplug the motors. those cables out of the way. There's all my motor cables. And I do have some smoothers on here, but with the TMC 2209s being 256 microsteps, I probably don't need them, but I use them anyway. And here is my extruder. Smoother over there. Put the extruder cable through. All right. And then these, all my end stops. I won't be needing these anymore because I'm going to do sensorless homing. Just put a block above them and hope for the best. If I can get rid of anything and still keep accuracy, I'm gonna do it. One more here. All right. Goodbye, electrical tape. There we go. And we'll pull these out. Okay. Next, I have these printed, mainly for support because the plastic corners on here, these they bend and wobble when you're at high speed, so the whole thing will kind of shake around like that, and you don't want that when you're using a Delta printer. So I'll take these out. Ugh. Yeah, this part's going to take a while. Funny thing about these is you print them to try and make your printer more accurate, but if your printer's not accurate, then you can't print them straight, and when you put them on, your printer's still not accurate. So it's best to get your printer as accurate as possible before printing these. Maybe print them super slow so there's nothing holding them back, and then once you have them installed and confirm everything's straight, then you can really ramp up the speed. But I don't think I'm going to have that issue because I'm putting metal corners on, so there shouldn't be much flex going on anymore. That. All right. Rip all this and pull this off. I'll have to slide the belt through the center. Something's catching somewhere. Come on. Get off there. There we go. All right. Use the belt to the slot. There's that. And our end stop wire right here. Move on to the next one. we go. Get these ones. There's number 2. Right over there. Whoa. And we're on to number 3. That out. This out. Next. Alright. And I know you can't see the back, but I'm just doing the same exact thing. Alright. This thing out. Of course, this one's got to be difficult too. Come on. Get out of there. It doesn't seem to want to. There we are. Right, here. And at least try to keep all our screws together. These ones. Alright. And I think that's all my screws. Cool. So, next, pop the screen off. And we are not going to be using this again because I got a new fancy screen. This one. Alright. And here's this one. Alright. Make sure I keep everything together. Come on. Alright, there's my screen. Throw this over here. Here's my little light controller. It's just a cheap LED strip from Amazon. It's got a button on it. I like it. Works good. It's not the brightest thing in the world, but gets the job done. These are always hard to take out. I'm sure I can just wait until I've got the corners off. Alright, Now, work on the top. So I will angle go up towards the top. Right there. Come on. There we go. All right. Slide out of the way. So first, we'll pop off. Oh, those are tiny. We'll pop off the M2s that hold the belt. And those are these right here. This little M2 with a washer on them. These things are on there. Go. And before I do that, let me show you why I'm upgrading to linear rails, because I think this is pretty important. So these essentially dictate how well your print is going to turn out when you're at high speeds. If they angle it so you can see, if they can move like that, you're probably not going to get the best prints. This one was the worst one. This one's super loose back here. But yeah, you can see that happening. And when these are connected to the rods, connected to the effector will wobble all around if these move at all. So linear rails do not move quite nearly that much. And that's why I'm using them. But another thing about linear rails is I got one right here that I'm going to use as an example on how to build them properly and tune them. But they do not arrive in good condition. This one's actually not awful, but the other two I got, you could barely move them. They'd get stuck and jammed, and they were grindy when you moved it, and they were just awful. I would never put that on a printer, but luckily I know how to fix that. That's with these and some of this and some of this. So show you how to do that later on. Really not that hard. A lot of people are scared to take their linear rails apart because they say the balls go everywhere and all that. Just be careful. It's really not that big a deal. Now, these little tiny M2 screws you do not want to lose when you're taking your belt off. Same with the washers. We will pop that out of there. There goes that belt. And then there goes the other side. Slide that down. Another thing, it's not very smooth on here either. Not the best. So I'm going to pop these M2 screws back in, make sure I don't lose them, because I will be reusing these aluminum carriages. Love them things. It's one of the better upgrades I did to this in the past. Man, are these tiny. All right. And then take these M3 screws out. Take them out of the sliding gantry here. One. Number two. And yeah, as I'm wrenching on this, I can see that gantry plate flexing. And if it does it with a little bit of torsion from my Allen wrench, then it'll probably do it while it's moving at high speed. So luckily we're replacing those. Here's the last screw. Goes that. Now, that's inside. Go. I'll take these wheels off. I'm just going to take the one off so I can get the gantry off. One. I'll screw that back in just to keep everything pretty contained. All right. And then here's my old belt right here. We'll throw that. Put these over here. All right. And then here's my carriage. Throw that over here. And since I already showed you all that, I'll just pop this gantry and belt off. Slide this guy off of here. And slide him off of here too. There we go. Back these back down so we don't lose them. The little M2 screws and the carriage. And then that back in. And we'll take those apart later on. Oh, we're moving. Get this teardown going. Where we at? 5 o'clock? Cool. 5 o'clock somewhere. All right. Drop the belt to. Bring him over here. And this one's next. This one's got one of them springs on it because I was testing them out, testing the tension. Seemed to work pretty good. And another reason that I'm using those springs is normally with deltas, you use a little screw screw on top to tension them, it's a bad idea. Because then you end up grabbing this top plate and shifting it one direction, back and forth, left to right, and we want precision. We do not want that. We want everything to be perfectly square. Put these back in. Alright. And then we'll pop this carriage off. Alright, carriage is off. And then we'll grab this belt. Take that spring out. Okay. Next up, we will grab all our tools and then start taking these out. I also have those little corner pieces up here. As you can see, they're kind of strengthen up the top. Guarantee I will not need those anymore with the aluminum rails or the aluminum corners, but I guess we'll see. Run some test prints, run some I forget what Clipper calls it. I haven't used Clipper yet, but some vibration tests essentially. Stuck on there, aren't you? All right. Pull all that apart. Let the screws do what the screws want to do. Go ahead and pop out the little 2020 rail retainers I got here. Maybe. There we are. Like to get this extruder wire out. That one. And I got one more. When I'm prying these out, I'm being sure to be very careful with the wire, not pry on the wire, because as you can assume, that'll cause all sorts of issues. Alright. My little extruder wire containers. And I can wrap this up and put it with the other stepper wires right over here. Alright. Leave that. Move on to the next. this corner off now. This corner bracket, not the actual corner. And then we'll loosen these ones up too while we're at it. All right. There goes the T-nut. And this one too. All right. We're almost completely down to the basic frame. Woohoo. Next, go ahead and take off the end stops. Size of these, of course. The one I don't have in my own set. Should be this one, right? Oh, this one. All right. Pop these little end stops off. Go. This one, you guys can see, right? Sort of. As good as it can from that far away. There's that one. And here goes this one. Alright. Then next I'll take off these top screws I was talking about. Do not need those anymore. Open that. Good stuff. Now we're ready to start popping some corners off. Taking some aluminum extrusions out. Loosen that up a bit. Loosen this up a bit. And loosen this one up a bit. There we go. Slide that off. Got to do it equally, but there's the top. Now my table's getting a little crowded, so we're going to move some stuff off so we can just focus on the frame. Right. All this. This. All right. We're getting there. Belts, power supply. Smoothers and stepper wires here. Extruder wires, or extruder brackets and the motor. We'll leave the motor here actually. Alright, here goes the extruder. Corner supports. That is a lot of screws. Come on. There we go. All right. These we can just move off to the side. Those over. Okay. Throw away the trash. These bolts. Actually, not the ones. The crush washers over here. These two, I'm not going to use them. All right. Now what we're going to do, take all these switches off, and stop switches. And then take these stoppers off as well. Anyway, might need to turn my exposure down. Getting pretty bright. Let's see here. There we go. That's better. Or not. Turn down some more. How's that looking? There we go. That's better. Okay. Let's grab this one. Those. We got everything off the top. Now we'll go for the bottom. Zoom up a little bit. Oh yeah, she's in there. Go ahead and take them all the way out. There we go. Lights out. There's one vertical extrusion. I do want to check and make sure they're still straight, which it looks like they are. Yeah. Generally, you can look down the center hole. Here. See if I can line this up right. Look down the center hole. And if it looks funny, then it's not straight. If it looks straight, then it's straight. See, that makes sense. And then we can yank out our in-stop wire. Go ahead and turn this. That guy all the way out. And take this guy all the way out. And all I'm doing here is taking this top screw and this bottom screw out of the corners. Slide everything off. Make sure it's straight. It looks like it is. Looking down the edges too. Yeah, this one might be a little bent. Yep, she's a little bent. Lightly work that out. That's good enough. Yeah. All right. And then get that wire out from the in-stop. Move on to the next. straight. There we go. Now, another good thing to check is make sure these are exactly the same height. Usually if you buy them in a 3D printer kit, they are, but you just want to double check. Because we'll be using that as a reference to make sure everything's square and everything's installed correctly. So here I'm just pulling out my little lights that I made. Yank out this end stop wire as well. Then I'll go ahead and move the end stops out of the way. We won't be using those again. All right. Okay. I will be putting the lights back on because it's better for visuals when you're doing a time lapse or whatnot. I'll try and get all these out of there. There is quite a few. All right. It's good to me. All right. We have our top, bottom, and the vertical extrusions. Start taking this top apart. Let me bring it all in closer so you can see what I'm doing. Every time I move the camera, it cuts out, so it's probably going to cut out. But we will see. There we go. So, first things first, I'm going to take these rollers out. So, in order to do that, I'm just unscrewing this right here. Actually, need to hold that nut. I don't know if y'all can see it. That nut right there, spinning. You just hold that in place. Nut. There goes my smooth split pulley. We'll do the same for the other sides. Make sure y'all can see what I'm doing here. Those. Next side. All right, there's all that. Now, that'll give us access to these screws right here and right there. So unscrew those. And before I show you that, let me kind of show you what I was talking about these not being accurate. You can see there's a gap right here, a gap under here. They don't sit flush. And then one of them, you could see it really well, but they were starting to curve and lift away. You can kind of see it on this one right in here. Curves and lifts away from the extrusion and ends up just warping and not being very nice to you after a while. So, okay. So, loosen everything up. Right, loosened. I tend to hold it up here more so I can see. And you don't got to take them all the way out, you just got to get them loose. Those loose. Seems like it's loose. These two are not. That one. This one. Alright. Now, I'm going to kind of just work them off evenly so you don't end up bending anything. There's one. Two. And there's three. And now, same thing for the side. And, I think in the actual video of this, I'm just going to do a time lapse for it because don't nobody really want to listen to me explaining that I'm undoing a screw 15 times. We're getting there. This is probably the most annoying part of the process of building a Delta printer. These corners, screwing them in, making sure they're straight, making sure they're all tight, unscrewing them. Not great, but I like Deltas. I've had a Cartesian before, and they're nice when you just want to rip out a couple prints and not get too technical and all that, but I like to get technical. I like precision. I like everything that goes into it, so alright, so we're pretty good on top. Flip her over and get the bottom. All that noise in the background is my cat messing with stuff. Probably knocking stuff over, breaking it, whatever. She's a kitten, I'll let her play. Ooh, that one is already loose. That's another thing. I'm going to start Loctiting these now so they don't come loose, because I realized probably about a quarter of these frame screws were already loose. So we don't want that later on down the line. Loose. Oh, yeah. I know I'm missing something. I just don't know where. I gotta be, because there ain't no way I just did them all first try. Come on. These ones are still a little snug. Loosen them some more. There we are. These are a little snug. There we go. Start sliding them out little by little. I have to loosen them as I go. There we go. These ones. Oops, these ones. And I'm going to just keep going down the line until they're finally off. I really wanted to sit here all day. I'd unscrew them all the way, but I don't know about all that. This one seems a little snug. Oh, yeah. Go. Alright. Cool, yeah. Take them all the way off. Get our bars. Once you kind of get it pulled apart, it's a lot easier to tell where it's getting snagged. It's holding it up. Yeah. Oh. Last one ain't being that nice to me. Gotta kind of work it until you get there. Screws all the way out, but it doesn't want to be nice to me. There we are. Now we have these. Go ahead, take off the steppers. I want to get these M4s out. so you can reach down in there with your Allen key. This is the part that I remember liking the least. Way back when I built this thing, I think this is the first Delta printer that Flsun ever came out with, and I think it's also one of the first Delta printers that was commercially available, and they still sell them today. Pretty neat. If I can get it to spin with my finger, that'd be fantastic. I doubt I'll be able to. There we go. There's another trick. You can stick your Allen key in there like that once you got them cracked loose, and just screw them out like that. Put some pressure in, but a little bit faster. Alright, there's one. Here's screw number 2. Side. Screw number 3. Make sure y'all can see this. Sorta. Three's out. We're on screw number 4. Alright. So there's our stepper. We're going to be taking this off and putting the new ones on. It's always a good idea to kind of check out your steppers, turn them a little bit, very slowly, don't wrench on them, and then give a little side to side, up and down, in and out. And bearings seem to be good on this one. There's no movement, turns smooth, there's no catching, so go ahead and keep that. Move on to the next. Wipe this off, get her looking all pretty again. And then side to side, up and down, in and out. And it turns nice and smooth. Now, these motors, I think, are, let's see, 1.5 amp. If I was going to upgrade, I'd probably go with the LDO motors that are 2.5 amp. And then run a SKR3 Easy and run just the motors at 24 volt. I bought the SKR3 thinking I can choose between UR and SPI and regular, and there's more options there for the steppers, but I also can only use 1 voltage. And I figured they'd be the same. They both have that voltage difference, or that stepper motor voltage singled out, but they don't. So I'm just going to run at 12 volt. Not terrible. Just a little less torque in the motors, a little more heat in the motors, but I'm not doing anything crazy with this printer. I'm just doing some basic performance upgrades, so won't be too awful. Now in the future, I'm building a very high performance Delta, and that is going to be running at 48 volt. We can move you back over here again. Yeah, that'll be running at 48 volt. It'll be all-wheel drive, using the Big Trees Octopus board, and that one I'm gonna build right. Doing all sorts of research on it. It's gonna have obviously metal corners, and it's gonna be built with 2040 rails as the vertical, and then 2060 on the bottom for horizontal, and the top actually, because I'm putting motors up there too. And my cat turned my sink on. I gotta do that. All right. Sure don't make these easy to get into, do they? Take this M4 out before I can take the M3 out into the stepper. Good times. I think when I'm done with this, I'm going to have to design a little Allen key ratchet that will fit in tight spots. This sucks. I'm almost there. Alright. Loosen this one up. long as I didn't strip it too bad. Now we can get it out. There we go. Break it loose. And zip them out. One. And here's number 2. Alright. And up, down, left, right, in, out. It's good. Spins nice and smooth. There we go. Do that test on the extruder too. Yeah. Extruder's got a different stepper on it. Feels a lot smoother. Might be a... That's one for me. Alright. So, there's the teardown. This is the frame. Should probably take these off too, but I'll do that while I'm talking. But yeah, this is the frame. Once I get everything taken apart here, go ahead and start on the new frame. Start putting it together. And that'll probably be a part 2. Don't want the videos to get too long. Throw them into a playlist, make it a series. And we'll get this thing built. Alright. Now we're done with the frame. So, there it is. We're all torn down. Next video, I'm gonna rebuild the frame, show you how to do some linear rail mods, some upgrades, make them all smooth. Because this one, you can probably hear that, it's not very smooth, and it's only going to get worse. And then I'll teach you how to square everything off, make sure the frame is a good, solid foundation for your printer. If it's not on the Deltas, there's some funky stuff that can happen. A lot of it can be taken care of in software, but you generally want to start pretty square with everything, pretty solid. So, yeah, I'll show you some tricks and see what we can do. All right, we're going to go on a break real quick.